So wonderful good morning, dear LinkedIn community and composites experts out there. So this is my week, my composites week, Composites 360 on tour. Today my tour comes to Aachen, to the wonderful city of Aachen, which is very close to the Dutch border. And I may introduce you Waarden. He's an expert in thermoplastics. Let me introduce you to Waarden. Waarden, maybe for the community, just a few words about yourself.
I have already a quite long career in composites and thermoplastics. I started more than 35 years ago at Fokker Aircraft, designing composite parts. At that time, still thermoset, but already quickly I also introduced, together with, say, some people from Delft University that moved to Ten Kate at that time, introducing the first thermoplastic composites and also introducing, so on my side, introducing the first thermoplastic composite parts in the aircraft at that time. Also doing, say, research on thermoplastic composites, on the processing.
So you see, I'm here together with the experts, from the aviation and thermoplastics situation.
Later then I switched to DSM, worked in application development, automotive, so more injection molding materials, also LFT, say long fiber materials. Then later 15 years working at SABIC, also application development, again automotive mostly, also material development, so the long fiber polypropylene injection moldable material, and also later started the development of unidirectional tapes for hybrid applications, which resulted then, for instance, in the acquisition of FRT tapes by SABIC, and also the further development of unidirectional tape materials. And since 3 years now, I am at AZL as design leader, so leading a small engineering team and doing a lot of projects, a lot of them on battery boxes.
So, Waarden, we are at a very traditional place here. Tell our community where we have met. We have obviously not met at AZL that we did last time when we hold our Composites launch conference at the RWTH campus. Where are we here today?
Now, here we are today at IKA. That's the Automotive Institute. There are a lot of institutes here on the university campus. The Automotive Institute is a quite big institute with all kinds of testing equipment. Here we are in a hall where they have several drop towers. We are here at a kind of medium-sized drop tower. They have even drop towers of 10-meter height, so they can do huge energy impacts we choose the medium energy impact, which is quite suitable for testing underbody protection plates.
Community, so this is the drop tower we are talking about, and we will show you a real-life test in a short moment, and you will see how we try to destroy a composite, but I can tell you already now it's not possible to get that high impact that composites shatters around. Yeah, you will see. Stay tuned. So, Waarden, tell us about why is impact such an important feature that you have asked this institute to make some tests on the composite parts?
So for the electric vehicles today, say it's very important that say when you drive at high speed on the road and you drive over just by accident over a metal object, that it could be swung up to the bottom of the car, and it might penetrate the bottom of this battery box, which is typically below you. And when it penetrates, it damages the battery cells. And today these battery cells are very high energy cells. They go into thermal runaway, and the whole car will result in a fire and a loss of the car. So it's really important to have a very good protection of the bottom of this the battery box, and therefore it's also good to test materials where they will at what energy level they are penetrated, and what energy level is safe, and to test it also under an angle, which is more realistic, say, to what happens could happen in practice.
Yeah. So you have a part here. Maybe you can show it.
Okay. The plates that we are testing are quite large plate, but still quite handleable.
This is a rectangular, and it's a normed shape. It's always the same shape, right?
Yeah. It's 40 by 40 centimeters, and it's bolted along the edge to really clamp it, which is, say, when you impacted it, you have this kind of, say, the same stress levels, tensile stresses, out of plane stresses, as you would have in a real bottom protection plates. Here, in this case, the material is composite. It's even a combination of carbon fiber on the outside. In the core, it's glass fiber. The rest is polypropylene. It is one of the many choices of materials that are proposed today as a more lightweight or maybe even cheaper solution than the more common today steel and aluminium bottom protection plates.
This is several layers.
It's this one is made from unidirectional tape that has typically a thickness of something like, it depends from manufacturer to manufacturer, but say 0.2 millimeter. This is a relative thin plate, maybe only 4 millimeter. Typically plates would be maybe thicker, maybe 5 millimeter or 6 millimeter, but it's all about finding the right level of protection and the right layer with the right directions of the unidirectional tape layers.
Yeah. So Warden, let me take this plate, and you take the. How do you call this actually?
This we call the dart.
The dart.
Yeah, actually,
the dart, like the sports playing dart.
Okay. And of course it's fixed to say extra weight and then it's dropped, and then it hits the plate under an angle, which means there could be some sliding, but there could also be penetration, and that's quite complex load.
So you will see this in a moment with the drop tower, which is in our drop bag, and this is basically the dart, and the dart's purpose is basically to damage this part and impact on it. But show again the angle. Is that more or less the angle I'm holding? So it will be not like this, not horizontal, but it will be impacting on an angle, right?
Yeah. Now we typically impact at multiple angles, at say perpendicular, so just 90 degree, 45 degree, or 25 degree. And then we cannot use this dart. Then we use a different dart, because otherwise the dart would already hit the edge of the clamping frame. And that's basically because it's more realistic that parts hit under an angle. If you hit perpendicular, it's quite easy to penetrate. It's more difficult when you have some sliding of the dart over the material.
And let me ask you the following, Warden. What type of data do you collect?
Of course, the speed of the dart on the moment of impact is measured, but that is already predicted by the drop height and the mass. But the most important then for the material behavior is to collect the force deflection curve, and that's indirectly measured by an acceleration sensor. So it's called, mechanics is used there to calculate the force deflection curve. And on the force deflection curve, you can also see when you have first fracture of the material. So it's very good to also estimate, say, how much energy is absorbed inside the material until the moment it fractures. Apart from that, also the high-speed video is taken, so that you can really correlate it to specific modes of fracture that you observe.
The speed of the dart, as far as I understand it, is stipulated by the height of the drop tower. So you don't have a motor or something that forces it down. It's just gravity.
And to be honest, it's not like this 100 kilometers per hour or 150 that you drive on the German highways, because you cannot achieve that with a drop tower.
Yeah.
But we compensate that by using a higher mass.
Okay.
So it's all about the energy.
Right.
That's basically making, say, the real impact.
Okay, so you have an off trade between not achieving a traffic situation on an autobahn motorway where you have a high speed and the stone comes to your underbody or to that plastic or composite part. You do this by increasing the mass of the composite part.
And then we are quite close to specifications from German OEMs.
Yeah.
What we also do is that we test just aluminum plates as they are used today. Typically, it's aluminum, quite strong aluminum alloy, 3.5 millimeter thick. And then we see how much damage is occurring.
Okay.
And we look at, say, just the minimum acceptable damage before the battery cells are damaged.
Yes.
And that we actually take them as the reference level for the impact. And at least composite plates should have equal protection as the aluminum or steel protection plates.
Very good. So I would suggest, Warden, that we make a short break, conduct our testing, and then we will come back with a final conclusion on what we have done.
Okay.
Okay. So we are back. That was really a big, loud noise bang. I'm sure you have not felt it in the video, but it was impressive. Very fast though, but very, very impressive. So Warden, what is your conclusion on this test?
I would say this is a quite nice result. You see this is some damage on the entry side. It's quite limited.
Yeah.
If you look at the back side, then you can see that there is more spreading of the damage.
Yeah.
This is actually quite a good thing that this UD material spreads the damage to a larger area.
Yeah.
So the penetration is not very deep. This is a protection plate. There is still some space until the bottom of the battery box. So this would be a quite nice result.
So I'm seeing that some of the fibers, the carbon fiber, actually now I have one here, is basically really intact. Yeah, the fiber, the roving, the tow is still there. That means there is some emergency running behavior. It's not disintegrating. It still keeps everything together. This is good news.
Yeah, now of course the carbon fibers, but also the glass fibers are, of course, have a very high strength.
Yes.
And that's how also it dissipates energy by spreading the load.
Exactly. So we are seeing in the unidirectional, we are seeing the carbon fiber here, and now we see also the second layer, the glass fibers, right?
Yeah. It's a bit difficult to see because it's on the inside.
Yes.
Maybe on this side you can also see it.
You see the impact.
Yeah, at the impact side there is glass fiber below.
So once again, for our community, Warden, what would be a typical application for such a part?
It will definitely be the protection shield, say, under the car to protect underbody to protect the battery box, because it's so dangerous if you have some penetration. It will definitely lead to thermal runaway, to the complete fire in the battery box and loss of the car. So this is a very important safety part.
So we got this cell to pack project, partner project of AZL, and this is a part of your findings, and you can present these findings within that project, right?
Yeah. We look at multiple materials. We also look at metals, aluminum and steel. We look at thermoset materials, thermoplastic materials, but definitely this type of unidirectional, but also fabric type of composite materials can provide very good and very safe solutions.
Very good. So, dear community, this is now everything from the impact side. And now we are changing the location and we are doing our fire test with composites. Stay tuned.